Did you know that if the food processing industry stopped operating for just 1 week, the system that sustains 8 billion people would falter and plunge into months of crisis? Especially during the year-end festive season, when consumer demand surges and over 40 million tons of food are released to the market in just a few peak weeks, the pressure on this industry multiplies. Today, join us as you visit some of the most advanced processing plants to uncover the silent yet artful processes behind every familiar meal, where each movement of the machinery contributes to the flavor, quality, and completeness of the festive feasts we enjoy. From an 18th century home economics exam, apple pie has now moved far beyond the family kitchen to become a billion-dollar industry, with more than 400 million pies produced each year. The creation of a premium apple pie begins with the filling, where thinly sliced apples are placed into an industrial mixing kettle, along with brown sugar, butter, and cinnamon. The most remarkable feature is the oversized mixing paddle. It rotates in a slow but powerful rhythm, allowing each slice of apple to be coated evenly in a golden syrup without breaking. Meanwhile, the pie crust begins its own journey. Flour is blended with cold butter at a temperature of about 8 degrees Celsius to preserve small pockets of butter. These butter flecks are the key to creating the thin, flaky layers that emerge during baking, a secret few outside the industry know. Once the dough reaches the ideal elasticity, a sensor-controlled roller system automatically adjusts to flatten it into uniform sheets. The dough passes through a high-speed cutter and drops precisely into pre-aligned molds. In the next stage, a filling nozzle dispenses the apple mixture into each crust using steady pressure, so that the apples remain intact and the syrup doesn't spill. A crimping machine then shapes perfectly even edges, a task once mastered only by skilled bakers. Inside a convection oven set to 185 degrees Celsius, the crust separates into delicate, crisp layers, while the apple filling thickens and becomes aromatic after about 22 minutes of baking. As soon as the batch cools, the pies are transferred directly to an automated packaging line to preserve the fragrance, crispness, and structure crafted throughout the entire production process. If you ask 100 people what their favorite popcorn flavor is, 99 of them will say caramel. Every year, millions of tons of popcorn are coated in caramel in factories around the world, creating the golden glaze that has become synonymous with movie theaters, festivals, and celebrations everywhere. The process of making caramel popcorn begins in a pressure roasting kettle, where tiny kernels are heated evenly. Each kernel naturally contains about 14% moisture, so that when the water turns into steam, a sudden increase in pressure causes the hull to burst open, transforming the starch inside into light, airy flakes. As soon as the batch finishes popping and reaches the ideal temperature, the line moves immediately to the caramel coating stage to ensure the glaze adheres perfectly. Caramel is made by cooking sugar and butter to nearly 150 degrees Celsius, the temperature at which the mixture reaches its ideal thickness. The hot mixture is poured into a high-capacity mixing drum, where rotating paddles continuously stir, allowing the caramel to spread evenly over every piece without clumping. In modern factories, this process is often done twice. The first coating forms the base layer, and the second enhances shine and crispness once cooled. When the caramel layer has bonded perfectly, the batch is cooled with strong airflow to lock in the crunch, then passes through a separation system to remove broken pieces. Each year, more than 40,000 tons of fudge are produced in just the final 3 months, with pots of bubbling sugar heating across Europe and North America, turning this silky soft confection into one of the sweetest icons of the holiday season. There's a common misconception: fudge is not chocolate candy, but a type of sugar confection that requires extremely precise crystal control. The process begins when sugar, butter, and milk are cooked to the exact soft ball stage, the temperature at which the sugar has melted just enough to create a pliable texture, but hasn't yet reached the firmness of caramel. In factories, each batch of fudge is monitored using temperature and viscosity sensors more than 200 times per minute, because even a slight deviation of a few degrees will cause sugar crystals to form improperly, making the candy grainy instantly. When the mixture reaches the proper stage, it is transferred to a beating machine that breaks down large crystals and creates a cream-smooth texture. Immediately after, the hot fudge is poured onto a marble slab, a material that draws heat very quickly, allowing the mixture to set evenly without developing large crystals. Instead of being rolled thin like many other candies, fudge is folded, turned, and gathered repeatedly, creating its signature soft, pliable, velvety structure. Once it reaches the ideal consistency, confectioners cut it into uniform blocks, each piece retaining its smooth surface and melting-your-mouth texture that few candies can rival. Farewell to the fudge production lines. We now enter an equally sweet, yet far more spectacular world, the industrial cookie ecosystem, where over 30 billion cookies are baked each year, making it one of the most consumed products in the United States. If apple pie dough requires gentle handling to preserve its buttery layers, cookie dough demands a firmer mixing force. Flour, sugar, and butter are beaten until they reach a moist sand texture. When eggs are added at just the right moment, the mixture binds together perfectly to embrace flavors like chocolate chips, almonds, or vanilla, the foundation for countless cookie variations. Once the dough reaches ideal consistency, it is transferred to the shaping machines, where more than 400 extrusion nozzles continuously press dough onto the conveyor belt. Here, rotating cutters stamp out a wide range of shapes, from classic round cookies to the signature patterns of each brand. The soft, unbaked cookies are set directly into a conveyor oven stretching nearly 60 meters, where circulating heat allows them to rise slightly, set their structure, and lock in their iconic, sweet, buttery aroma. If fudge is the soft, melt-in-your-mouth candy, then toffee is the sturdy block of caramel that dominates factories with overwhelming production volume. Toffee begins with ingredients that seem simple: sugar, butter, cream, and a pinch of salt. But unlike fudge, which relies on precise crystal control, toffee is cooked to a high temperature of about 150 to 155 degrees Celsius, where the sugar undergoes deep caramelization, creating the crisp, brittle texture no fudge can match. As the mixture begins to thicken, cream is added to enrich the flavor and balance the sweetness. Few people know that just a deviation of a few degrees can change the entire result. Toffee may become perfectly crunchy and snappable, or harden like glass. The mixture is then poured onto a metal surface for rapid cooling. As soon as the caramel reaches the threshold of setting, sharp blades cut the toffee into uniform blocks, with each cut precisely calculated to avoid cracking the delicate structure. Next, the pieces of toffee pass through a stream of melted chocolate, where a smooth coating envelops every surface. While the chocolate is still warm, crunchy roasted almond crumbs are sprinkled on top, creating the familiar traditional flavor. In many factories, this step is reinvented with countless different toppings, each adding its own distinct layer of flavor and texture. This versatility is what allows toffee to break free from the mold of traditional caramel and become a confection with hundreds of variations around the world. If apple pie still carries the warm, home kitchen charm, then cider is its fully industrialized counterpart. Each year, the world produces more than 20 billion liters of cider, turning the seemingly rustic drink into one of the most popular fruit-based alcoholic beverages on the planet. The apples are fed into an industrial steel roller grinder, dozens of rotating blades spinning at over 1,000 RPM, chop, shred, and compress them into a uniform mash of pulp and juice, maximizing extraction from every single fruit. The crushed apple mass is transferred to a pressing system to separate the juice, which is then pumped into fermentation tanks. Here, yeast converts the natural sugars into alcohol and releases the signature aroma of cider, a process that lasts anywhere from 7 to 21 days, depending on the production style. When the cider reaches its desired clarity and flavor profile, it is filtered, adjusted for alcohol content, and bottled. From whole apples to finished beverages, a closed-loop production line can yield thousands of liters of cider every hour. To produce a complete batch of eggnog, the journey begins with eggs passing through a strict inspection system. Each one must clear multiple quality checks before entering the automatic egg separation unit. In the past, workers had to crack each egg by hand, a slow process prone to shell contamination. But today, high-capacity separators can handle tens of thousands of eggs per hour. A gentle pressure blade opens the shells along the precise line, allowing the yolk and white to slide into two separate channels without ever being touched by human hands. The yolks are then blended and combined with milk and sugar to form the base mixture. Next, hot milk is poured into the yolks at a sensor-controlled rate, ensuring the mixture emulsifies smoothly without cooking or curdling the eggs. Once fully homogenized, the mixture moves into a heating system for pasteurization before entering a homogenizer, where high pressure breaks down fat particles and creates eggnog's signature velvety thickness. The mixture is then rapidly cooled to 4 degrees Celsius to lock in its texture before going into an aseptic filling line, capable of processing tens of thousands of liters per hour, completing the production of this iconic holiday beverage. Did you know that creating a bottle of fine whiskey can take more than 100 years? 80 years for an oak tree to mature, and decades more for the spirit to rest in the cask. That's why whiskey is often called the liquid gold of time. The journey of a single drop of whiskey begins with barley still lying dormant. The grains are soaked, encouraged to germinate, then finely milled and mixed with hot water at 63 degrees Celsius to activate enzymes and release a sweet liquid known as wort. This mixture is transferred into fermentation vessels, where yeast converts sugars into alcohol and forms hundreds of aromatic compounds, the foundation of whiskey's flavor profile. When the fermented wash reaches about 8% alcohol, it undergoes 2 rounds of distillation to separate the pure alcohol vapors, raising the strength to nearly 70% ABV. The young spirit is then moved into oak casks whose interiors have been toasted or charred by coopers until the wood turns deep brown or even black. This cooked wood generates vanillin, caramel notes, and smoky undertones, core flavors the whiskey will gradually absorb. During the long years of maturation, the cask no longer contributes raw aromas, but instead becomes an environment where the spirit constantly interacts with temperature changes and oxygen. Each cycle of heat and cold causes the whiskey to expand and contract, seeping deep into the wood to draw out tannins and structure, while about 2% of the whiskey evaporates each year, a loss known as the angel's share. Over time, the color deepens, the flavors round out, and the unique character of each cask emerges. When the whiskey reaches its desired maturity, master blenders craft the final composition, adjusting the strength before bottling, creating a whiskey that carries the distinct identity of its distillery. Born in the agave valleys of Jalisco, tequila quietly crossed borders, riding the wave of globalization to spread across the world. Each year, Mexico produces over 600 million liters, exporting to 120 countries. In the United States alone, its largest market, people consume more than half of the world's tequila, making it the second most popular spirit after whiskey. Unlike 3/4 of the world's liquors, which are distilled from grains, tequila has a truly unique origin. Born from the blue agave plant, a symbol of wildness and instinct, it was made to ignite the senses, bold, unfiltered, and full of character. But with an alcohol content of 35 to 55%, just a few shots are enough to scorch your throat and push your limits. Still, not every glass of tequila is real. The pure spirit labeled 100% de agave is often overlooked, gradually replaced by tequila mixto, a diluted version mixed with sugar and syrup to cut costs. That's why drinking tequila isn't just about pleasure. It's a test of character. To choose the right bottle, sip slowly, and savor it knowing exactly what you're drinking. So, what is it within the agave plant that creates the magic, making tequila so distinct? Let's head to the highlands of Jalisco in western Mexico, where the iron-rich red soil helps agave plants grow up to 20% sweeter than those from the lowlands. Before earning global fame, every agave begins its journey with meticulous care. It all starts here, when the mother plant produces small shoots called hijuelos, sprouting across the sun-drenched agave fields. Each year, a single plant can produce around 5 new offshoots. Farmers carefully select the strongest among them to continue the life cycle. From there, the young agaves grow slowly, drawing minerals from volcanic soil and sunlight to build up their sweet core. After about 6 years, the plant begins to mature, but only around the 9th year, when all its energy has gathered in the heart, the piña, is it truly ready for harvest. Across vast green fields where each agave plant takes 6 to 8 years to mature, the harvest doesn't rely on machines, but on human hands, the jimadores. Under the scorching sun of the Mexican highlands, they begin by cutting away the sharp leaves, leaving only the pure white heart near the plant's core. Using a koa, a tool with a round blade shaped like a machete, yet handled with the precision of a sword, they skillfully pry each heavy heart from the earth with firm, practiced strokes. This technique may look simple, but it demands endurance, precision, and years of training, for even a trace of the plant's bitter sap can ruin the flavor of the tequila. Continuous chopping, however, quickly dulls the koa blade as it strikes tough fibers and soil clinging to the roots. That's why before each new cut, jimadores sharpen it swiftly with a small steel file they carry with them, restoring just enough edge to slice cleanly without damaging the flesh. A seasoned jimador can harvest between 100 and 300 agave plants a day. And from these fields, thousands of tons of piñas are loaded onto trucks each year, bound for the distilleries where tequila's transformation truly begins. At the beginning of the journey, roasting in stone ovens is the most iconic step in the traditional tequila making process. Workers dig deep, cone-shaped pits into the ground, line the bottom with volcanic rocks, then burn wood for hours until the heat spreads evenly throughout the pit. Once the temperature is just right, the piñas are stacked in layers, covered with dry agave leaves, fibers, and soil, creating a natural underground oven. Most artisanal brands, such as Gran Patron Smoky or Siembra Valles Ancestral, slow roast the hearts for 5 to 7 days, allowing the starches to gradually convert into sugars while absorbing the smoky, woody, and mineral aromas. This slow transformation infuses the agave with deep notes of caramel, smoke, and earth, a signature richness that no industrial steel oven could ever replicate. After roasting, the surface of each piña turns a gleaming amber hue, while the flesh inside becomes soft, aromatic, and sweet. They are left to cool naturally for several hours, allowing steam to escape and the fibers to relax. Once the temperature stabilizes, workers use hand-forged steel axes to chop the massive piñas, each weighing up to 100 kilograms, into smaller pieces. Each strike is not just an act of strength and precision, but the first true step in transforming the piña into tequila. The chopped pieces are then gathered and left to breathe for a few more hours before moving on to the next stage of conversion. At this stage, the roasted agave is taken to a traditional stone mill pit, where a massive tahona wheel, weighing nearly 2 tons, slowly rolls over each batch of softened fibers. In the past, this stone wheel was pulled by donkeys or oxen, but today it is mostly powered by slow-turning motors that preserve the rhythm of traditional milling. As the tahona rotates, a worker stands nearby, using a rake to turn, spread, and guide the agave pulp back into the wheel's path, ensuring every strand of piña is thoroughly crushed but never pulverized. The tahona doesn't just extract the sweet juice, it also retains part of the fibrous pulp, an element that gives the tequila a fuller body, natural smokiness, and a deep, lingering finish. The honey-like liquid collected from this process, called aguamiel, carries all the sugars, minerals, and aromatic compounds of the agave. This sweet nectar then flows through a network of pipes into large fermentation tanks, ready for the next transformation. The traditional method is still preserved today, but as global demand continues to rise, producers have had to adopt modern production lines, both to reduce manual labor and to maximize output. That's why our journey now takes us to large-scale tequila distilleries, where hundreds of millions of bottles are produced each year to supply markets across the world. Unlike the artisanal process, in modern facilities, the agave hearts are simply split in half before cooking. This task is still done manually. Workers wield large axes or machetes to cut through the tough cores, allowing the piñas, each weighing tens of kilograms, to steam more evenly in industrial ovens. Every decisive strike not only paves the way for mechanized processing, but also preserves the human touch, a lasting mark in the journey of creating tequila. Right after being chopped, the piña pieces are placed onto steel conveyors and carried into massive steam chambers. Inside, steam is pumped in at a pressure of around 1-2 bar, maintaining heat for many consecutive hours. This method allows the starches within the agave core to convert into natural sugars much faster than in traditional brick ovens. However, the trade-off is a cleaner but lighter flavor, lacking the distinctive smoky caramel notes once imparted by fire and volcanic stone. After cooking, the piñas are crushed to extract the aguamiel. In this stage, mechanical milling systems equipped with continuously rotating steel rollers both press and spray spring water over the fibers to fully extract the remaining sugars and aromas from the agave pulp. This method achieves up to 98% sugar extraction efficiency, making it ideal for large-scale industrial production. However, it also removes much of the natural oils and fibers. For that reason, many modern producers still preserve part of the tahona process alongside, to retain the depth of flavor and the artisanal character that define traditional tequila. At the fermentation stage, both the juice and the remaining fibers are poured into large steel tanks. The crushing process takes about 2 hours to extract all the liquid. From there, the resulting mixture is piped into huge wooden vats, where yeast is added, allowing the sugars to begin their transformation into alcohol. The yeast multiplies rapidly, consuming all available sugars and producing alcohol along with CO2. Within about 30 hours, most of the sugar has been converted into alcohol, and after 72 hours of fermentation, the mixture develops a slightly sour taste and fills the air with a rich, distinctive aroma. Immediately after fermentation, the liquid is transferred into distillation stills to separate the alcohol and remove impurities. The first distillation produces a crude spirit called ordinario, with an alcohol content of about 20 to 25%. It is then distilled a second time to refine and raise the strength to between 38% and 55%. Traditional copper stills lend warmth, complexity, and a classic aroma to the tequila, while stainless steel stills in industrial production ensure precise control and higher efficiency. This is the pivotal stage where the spirit's strength and layers of flavor are defined. Afterward, the tequila is transported by tanker trucks to aging warehouses. There, in vast cellars, more than 9,000 American white oak barrels are kept under a fine misting system to maintain humidity and prevent evaporation. The finest tequilas are aged for up to 5 years, absorbing the essence of the wood and developing a superb depth of flavor. For more complex varieties, the tequila is aged for at least 2 months or longer, depending on its quality. During this maturation, it draws in the wood's character, acquiring its signature amber color and rich, rounded taste. And after all those transformations, the final spirit is ready for bottling. But first, it must pass a meticulous quality check through tasting. Once approved, the tequila is sent to the bottling line, where each bottle is placed upside down on a conveyor and rinsed with tequila itself to eliminate any trace of impurities. After one last quality inspection, every bottle is individually numbered, allowing it to be traced back to the exact distillery where it was made. Each year, this facility ships out up to 420,000 barrels of tequila, distributed to markets across the globe. If you ever have the chance, visit the state of Jalisco, because nothing compares to standing amid endless agave fields, breathing in their distinctive aroma, and feeling the spirit of Mexico all around you. Here, tequila is more than just a drink, it's a living culture, flowing through family-run distilleries, bustling markets, lively street bars, and the free-spirited people themselves. Together they form the pure essence of Mexico, a place where every color, sound, and flavor intertwines to tell one timeless story, the story of tequila. From giant pumpkin pies and crazy festivals to the spectacular orange rain, it all begins with a meticulous and bountiful pumpkin harvest process. The golden window for harvesting pumpkins is from September to November, when the fruits are perfectly ripe, stems have turned woody, and the skins have deepened to a rich orange, ready to leave the fields and enter the bustling holiday season. Harvesting pumpkins used to be back-breaking work. Dozens of laborers would bend over to cut each fruit by hand, often tearing stems or bruising the skin due to inconsistent handling. To meet the enormous demand of the processing industry, the sector had no choice but to mechanize the process. Across vast pumpkin fields, modern harvesters glide gracefully along the rows, collecting each pumpkin with care. Fruits are gently lifted from the ground, even those hidden beneath thick leaves, then pass over vibrating conveyor belts that blow away dirt, dry leaves, and other debris. On the next conveyor, each pumpkin is thoroughly inspected to ensure quality before being loaded straight into storage bins. Thanks to these intelligent systems, productivity soars. 20 to 30 tons of pumpkins can be harvested per hour while preserving their shape, skin, and vibrant orange color. Compared to traditional hand-picking, this technology is the key to controlling the exact timing of pumpkin intake for factories. Even a single day's delay can trigger enzymes that destroy 15 to 20% of a pumpkin's natural sugars. That's why all pumpkins must be processed within 24 hours to retain their flavor, firmness, and signature orange hue. The essential qualities that define millions of perfectly crafted pumpkin pies throughout the holiday season. Beyond the pumpkins harvested for their orange flesh used in fragrant pumpkin pies, there are also fields grown entirely for seeds. On these neatly arranged pumpkin rows optimized for mechanization, the seed harvesting system operates in a completely different way. Instead of gently lifting the fruit to preserve its shape, a screw auger pierces straight into the pumpkin's core, lifting the whole fruit into a separation chamber and crushing the flesh inside the spiral tube. In the centrifuge chamber at the back, the strong spinning force releases thousands of glossy green seeds, which are then transferred directly into containers. Dry, clean, and almost free of pulp. The leftover pumpkin flesh is returned to the field as nutrient-rich green compost, high in potassium and cellulose, helping the soil retain water and naturally restore fertility for the next planting. From these tiny seeds, a wide range of products is created: omega-rich pumpkin seed oil, roasted seeds, pumpkin seed powder, and ingredients for dietary supplements. This green gold represents the most valuable component of the entire harvest. For pumpkins selected for processing, the moment they leave the fields and enter the factory marks the beginning of their journey to becoming the filling for millions of pumpkin pies. At the facility, the pumpkins enter a pre-processing system and pass through a recirculating wash tank, where high-pressure spray nozzles remove soil, sand, and mud from their surfaces. They are then transferred to a rotating roller system, equipped with fine mist sprayers that clean the stem sockets and recessed areas, the spots most prone to holding debris. Finally, the pumpkins move through a warm air-drying chamber for light sterilization, which both dries the surface and reduces microbial load before further processing. Beginning the transformation process, the pumpkins are fed into an automatic peeling machine, where stainless steel blades can handle both round pumpkins and butternut squash, up to 17 inches long. The peeling depth can be adjusted instantly with a dial, allowing the system to preserve as much flesh as possible before the pumpkins move into a hot water bath for about 90 seconds to soften. After steaming, the pumpkins are halved, deseeded, chopped, and sent into the grinder. Here, the flesh is ground into a fine consistency, then passed through a precision filtration system that removes all fibers, peel fragments, and impurities, resulting in a smooth, uniform, high-quality puree. To finish the process, the puree is heated to a stable temperature, sterilized using pressurized steam, and packaged in aseptic bags or large sterile drums, ensuring long-term shelf stability without preservatives. From here, it's ready to be shipped to food manufacturers, including giants like Costco. To create a flaky crust that's crisp and layered, yet still tender and moist, choosing the right butter is a step that cannot be skipped. Factories use industrial butter with over 80% butterfat, as it's rich in milk fat and maintains structural stability during baking. Before mixing, the butter is cut into medium-sized cubes, not so small that they melt too quickly, but large enough to maintain surface contact with the flour. Most importantly, this entire step is done while the butter is still cold to preserve its solid structure, the key factor behind the crust's signature flakiness once baked. Next, the butter is combined in an industrial mixer with flour, cold water, and salt. The machine operates at a slow speed, about 30 to 40 RPM, meaning a 150 kilogram batch of dough takes roughly 3 minutes to mix to perfection. After mixing, the dough is rested to allow the gluten to relax and the butter to re-solidify. Then it's moved into the dividing and rounding system before being pressed into non-stick metal tins, forming a stable, uniform crust that won't crack during baking. At this stage, the production line reaches the step that defines most of the pie's flavor. In the mixing area, pre-weighed dry ingredients, sugar, salt, cinnamon, ginger, and allspice are poured into an industrial mixer, followed by pumpkin puree, sweetened condensed milk, evaporated milk, cream, and eggs. As the mixer blades turn, the mixture gradually develops its signature golden hue, while the texture becomes smooth, rich, and pliable, forming the classic custard base for the filling. Once perfectly smooth and uniform, the mixture is pumped into a holding tank, kept warm to prevent separation or skin formation. From there, the filling is directed to the depositing area, where workers control stainless steel dispensing nozzles to accurately pour 40 ounces into each pie mold. Each iconic Costco pumpkin pie weighs approximately 1.7 kilograms with a 12-inch diameter, enough to yield about 12 standard slices. To complete the process, the pies are baked at high temperatures, with convection fans maintaining even heat throughout the oven chamber. After about 30 minutes, the filling turns a rich amber orange, and the crust achieves a light golden crispness, the hallmark of quality. Immediately after baking, the pies are transferred to a rapid freezing system to lock in the smooth texture and preserve the flavor. They are then packaged in the signature, large plastic trays, ready to appear on Costco shelves in less than 24 hours from the oven. Thanks to the filling's combination of sugar, fat, and dairy, a natural moisture-retaining trio, pumpkin pies can be frozen for 3 to 6 weeks, while keeping the custard smooth, free from separation or ice crystals. Best of all, when it's time to enjoy, simply allow the pie to thaw naturally. Upon opening, the custard remains rich and creamy, and the crust stays flaky and crisp, almost indistinguishable from a freshly baked pie. From around July to September each year, the tobacco fields enter harvest season. Harvesting requires great precision, relying on both experience and traditional principles. Specialized machines move slowly through the head-high rows of plants. Beneath them, a system of sharp rotating blades precisely cuts the mature leaves close to the ground. Immediately afterward, soft conveyors receive and lift the leaves, preserving their shape and moisture while minimizing tearing or bruising. Leaves must be picked when they are not too wet to prevent bruising, yet not too dry, which makes them brittle. The ideal temperature is between 20 to 25 degrees Celsius, and harvesting typically takes place between 5 and 9 a.m., when the leaves are still supple and retain a healthy sheen. The leaves are delivered directly into a large ventilated container at the rear, designed to prevent moisture buildup and premature fermentation. Once full, an automatic unloading system transfers the leaves to a detachable bin or a specialized truck moving alongside. On average, a single machine can harvest about 5 tons of fresh leaves per day, 8 to 10 times more efficient than manual labor, while also reducing risks and improving efficiency across the entire production chain. At some cigar tobacco farms, machines are used to harvest the entire plant. These devices cut the stalk at the base, gently lift the full row, and automatically hang the plants onto integrated curing racks, ready for drying. Notably, keeping the stalk intact allows sap to continue distributing into the leaves during drying, making them softer, more elastic, and rich in natural oils, crucial qualities for producing smooth, flexible, and glossy wrappers for premium cigars. In Cuba, Nicaragua, and the Dominican Republic, the birthplaces of hand-rolled cigars, the tradition of harvesting by hand is still carefully preserved, serving as a tribute to the leaves that will become the soul of premium cigars. Unlike the mechanical precision of machines, manual harvesting follows a slow, deliberate rhythm rich with craftsmanship. Skilled workers closely examine each leaf, using its color, sheen, and elasticity to judge the perfect stage of ripeness. After harvesting, the leaves are bundled into small groups and placed in woven baskets or breathable racks to maintain their shape. Though labor-intensive and slower, this meticulous process is what gives handmade cigars their unique value. Why a single premium cigar can fetch hundreds of dollars, while a pack of machine-made cigarettes costs just a few. From here, the leaves begin to diverge, some destined to become artisanal cigars, others entering the industrial pipeline of mass-market tobacco. Let's begin with the remarkable story behind every cigar. Not just something to smoke, but a product born from time, technique, and traditional craftsmanship. Immediately after being harvested, tobacco leaves enter the curing stage, the first and one of the most critical steps in cigar production. The leaves are hung in curing barns or sheds, where temperature, humidity, and airflow are tightly controlled. Depending on the leaf variety and desired flavor profile, different methods may be used. Sun curing, air curing, smoke curing, or heat curing. This process usually takes several weeks and requires great precision, as even small deviations can significantly impact leaf quality and the final cigar flavor. After curing, the properly dried tobacco leaves move on to fermentation, an essential stage for refining flavor and stabilizing leaf structure. The leaves are stacked into large piles called pilones, where heat naturally builds up through biological decomposition. During this phase, unwanted compounds such as excess nicotine and ammonia are removed, while natural aromas are enhanced. Workers regularly turn the piles to control temperature and humidity, and lightly moisten the leaves to maintain optimal conditions. Once fermentation is complete, the tobacco leaves are carefully sorted based on size, color, softness, and flexibility. Each cigar requires 3 types of leaves: the wrapper, outer layer; the binder, middle layer; and the filler, inner core. The wrapper is the outermost leaf, directly impacting the cigar's appearance and flavor. The binder holds the filler together, providing structure, while the filler, the heart of the cigar, is made up of several smaller leaves blended according to a specific recipe. This filler blend is what gives each cigar its unique flavor profile and signature character. For premium cigars like those from Cuba or the Dominican Republic, hand rolling remains the gold standard. Skilled artisans carefully select the appropriate filler leaves, arrange them according to a specific blend, then roll them tightly with a binder and finish with a smooth wrapper. Each cigar is shaped, the head is twisted, then it's placed into a mold for pressing and undergoes thorough inspection before storage and packaging. While each artisan can roll only a few dozen to a few hundred cigars per day, their precision and craftsmanship result in a level of quality that's unmistakably superior. Although the cigars are already complete in appearance, they still require time to rest. This post-roll aging stage lasts from 2 weeks to 3 months, allowing the tobacco leaves to blend and the flavors to stabilize. During this period, the compounds in the filler, binder, and wrapper gradually harmonize, creating a balanced aroma, taste, and burn. As a result, the cigars reach their ideal state before being packaged and shipped. Meanwhile, in large-scale factories, automated cigar rolling machines are used to boost productivity and standardize the product. First, tobacco leaves are fed into the machine and cut to pre-programmed specifications. Once the filler, binder, and wrapper layers are precisely arranged, A system of rollers tightly wraps them into the shape of a finished cigar. The head of the cigar is then neatly twisted by the machine to ensure uniform size and appearance. Next, the cigars pass through a preliminary inspection line before moving on to the next stage. Specialized equipment is used to assess the roundness, firmness, and tightness of the cigar's head, as well as the condition of the wrapper surface. Any cigar showing defects, such as loose rolling, torn wrappers, or incorrect dimensions, will be rejected or redirected to a separate category for further handling. After that, each cigar is carefully wrapped in a thin layer of nylon to protect its outer structure, maintain optimal humidity, and ensure complete hygiene. This wrapping also helps shield the cigar from environmental factors during transportation and storage, preparing it for the final packaging stage. And now, let's explore the cigarette manufacturing factories, where each cigarette is produced through a closed-loop process that is both rapid and highly precise. Unlike the artisanal craftsmanship of hand-rolled cigars, cigarette production is highly industrialized, driven by extensive automation and advanced technology. Unlike cigars, which require each leaf to be hung individually, tobacco leaves used for cigarettes are typically stacked in large cages or mesh containers, then placed into sealed curing chambers with automated temperature and humidity controls. These high-capacity systems operate continuously and can cure several tons of leaves each day. The drying process removes moisture and stabilizes the leaf structure, preparing them for further processing. Once the leaves reach the desired moisture level, they are compressed into tightly packed bales for easy storage and transport to the main processing plant. At the factory, the tightly packed bales of tobacco leaves are unpacked and fed into a modern cutting system. Here, the leaves are shredded into fine, uniformly sized strands, making them easier to roll into paper and ensuring a consistent, even burn in every cigarette. These shredded tobacco strands are then moved into a blending process that follows a proprietary formula unique to each brand. In addition to the primary tobacco material, the blend may include several additives such as flavor enhancers, humectants, and aromatic agents, designed to smooth the draw, adjust the scent, and enhance the overall smoking experience. The entire process is strictly monitored and controlled to ensure uniformity and maintain the final product's quality standards. Once the tobacco filler is ready, the automated production line feeds it into specialized rolling paper tubes, ensuring an even burn and controlled smoke output. The processes of rolling, cutting, attaching the filter, and shaping the cigarette are all fully automated, producing thousands of cigarettes per minute with high precision. Once the finished cigarettes meet quality standards, they are transferred to a fully automated packaging line, a highly precise and tightly controlled process. Every 20 cigarettes are neatly aligned and inserted into a specially designed cardboard box. These boxes are built to withstand transportation while also clearly displaying the brand's colors and imagery. Next, each pack is wrapped in a layer of foil or thin aluminum film to preserve the aroma, block moisture, and shield the contents from environmental factors. This is followed by an outer shrink-wrap plastic layer, which enhances durability and gives the final product a sleek, polished look by the time it reaches the consumer. Thanks to advanced automation, modern factories can produce hundreds of thousands to millions of cigarette packs per day with near-perfect consistency. And that is the meticulous journey, from delicate leaves swaying under the sun and wind to the iconic product of a multi-billion-dollar industry. Are you curious about how farmers cultivate the vast tobacco fields behind the billions of cigarette packs produced each year? That journey begins with tiny seeds carefully germinated in soil trays or greenhouses, where light, temperature, and humidity are strictly controlled. After about 4 to 6 weeks, once the seedlings reach a height of 15 to 20 centimeters, they are transplanted into the fields. Today, instead of planting each seedling by hand, many modern farms use specialized tobacco transplanters. These machines can automatically drill holes, place the seedlings, cover them with soil, and gently press the surface, all in a single pass. Thanks to this technology, thousands of tobacco plants can be planted in neat, uniform rows within just a few hours, saving labor while ensuring optimal spacing between plants. Tobacco thrives in loose, well-drained, nutrient-rich soil. Throughout its growth cycle, chemical fertilizers, pesticides, and herbicides are frequently applied to prevent pests and diseases and to ensure the leaves meet commercial quality standards. However, the heavy reliance on these chemicals silently contributes to soil and water pollution, posing a serious threat to the surrounding ecosystem. An often overlooked dark side of cultivating one of the world's most profitable industrial crops. Now, each time you hold a cigarette in your hand, the smoke you exhale carries more than a habit. It embodies the essence of the earth, the sky, and the hands that shaped it.